In this video, we're going to go over how to solve quadratic equations by factoring. And so if you want to pause this video and write this down, there is a little bit of room on your notes right over here, if you can cram that in. If that's not enough room, just get a separate sheet of paper. Here are the 4 steps to solving a quadratic equation by factoring. So the first thing that we need to do is to put the equation into standard form. Standard form is your ax squared plus bx plus c equals 0. And that equals 0 portion here, this is what we mean and what we're looking for. So the second thing you want to do is to factor out the GCF if there is one, which stands for the greatest common factor. Number 3 is to factor. And then number 4, we're going to use the 0 factor property to solve. So let's use these steps to solve our equation. So example 1, we're going to use factoring to solve the quadratic equation. Step 1 is to put this into standard form. This is in standard form. It already equals 0, so we're good there. Step 2 is to find a GCF. You have 1, 7, and 12. There's nothing you can divide into all 3 of those, so we are good. So the next thing is to factor. So when we factor, we kind of have what I would consider 4 different types of quadratics. And that's what these 4 problems represent. So this first one represents what I call an easy trinomial. It's easy because it's A is 1. Okay, there's no number other than 1 outside that x squared, so that makes it easy. And it's a trinomial because it's got 1, 2, 3 different terms. So when you have an easy trinomial, we already looked for a GCF. We don't have one, so we'll go straight into our x. Up here in the top, we're going to put our a times c, so that's 1 times 12. Down here is our b term. My b term is what goes with this x. And so you do need that sign with it. So this is -7. And so now you're looking for 2 numbers that add up to your b. But when you multiply those 2 numbers, you get to your AC. And hopefully you see that that is -4 and -3. -4 times -3 gives me a +12, but -4 plus -3 gives me -7. So once I have these 2 numbers, because this is easy, because my a is 1, this factors to x minus 4, x minus 3, and then bring down your equals 0. If you were to FOIL this back out, you would get back up to our trinomial. X times x is x squared. X times -3 is -3x. -4 times x is -4, and -4 times -3 is that +12. Okay, so once I factor this, then we're going to use that 0 factor property. The 0 factor property says for this to equal 0, either this product or this multiple needs to equal 0, or this one needs to equal 0. And so we will set both of them equal to 0 and then solve. So I've got x minus 4 equals 0. We'll add 4 over to both sides to get x equals 4. And then we'll add 3 over here to both sides to get x equals 3. And so those are my 2 solutions. And if you were to plug those in, we would get 0. You do 4 squared minus 4 times 7 plus 12, or if you do 3 squared minus 7 times 3 plus 12, both of those should give you 0. Okay, so that's the first one to factor your easy trinomial. This one here, notice we have a square term and we have a constant. This is my example with no b term. Okay. You have two of them, but you're missing that bx there in the middle. So when that happens, this is called difference of squares. And you want to, so first you want to go through those same steps. It equals 0. So it is in standard form. So that's step 1. Step 2, do these have any common terms that I can, common factors that I can factor out? And no, you can't divide 4 or 49 by the same thing. So now we go into factoring. Because I can recognize that I have no b term and that this is a difference of squares, you take the square root of both of these. 4x squared, the square root of that is 2x. The square root of 49 is 7. And because it's the difference, you have 1 plus and 1 minus. So if you are to FOIL that out again, 2x times 2x is 4x squared. 2x times a negative 7 is negative 14x. 7 times 2x is a positive 14x. So those cancel out. That's why we have no b term. And then 7 times negative 7 gives me that negative 49. So now that this is factored, we will use our zero factor property and take both of these factors and set them equal to 0. So I have 2x plus 7 equals 0 and 2x minus 7 equals 0. So on this first one, we'll subtract 7 over and then divide by 2 to get x equals negative 7 over 2. Here, we're going to add 7 over. So 2x equals 7. Divide by 2, and so x equals positive 7 over 2. You can again plug those in and see that you will get 0 whenever you do that. Okay, so on C, the first thing you want to look for is that it's in standard form, and this is not in standard form because it does not equal 0. We need to get this to equal 0, and we're going to do that by adding over an 8x to both sides. Here, these are not like terms, so this just becomes x squared plus 8x equals 0. So now this is in standard form. And this one is an example of, we have our ax squared, our bx, but now I have no c term. These problems seem to stump most, and these are actually the easiest because once I get this into standard form, my next step for solving is to factor out a GCF. If you don't forget this step, then these problems are easy. Every time after you get this in standard form, which means it equals 0, look for a GCF. This one, I have a GCF of x. They both have an x term, so I can factor out, let me move this down a little bit. I can factor out an x. When you factor out an x, what you are doing is you are dividing that out of both terms. So x squared divided by x is x, and 8x divided by x is 8. If you are to distribute this back, x times x is x squared, and x times 8 is 8x. This is in factored form. I can't break that down anymore. So by factoring out that GCF, I have now factored this out. So use your zero factor property. Your first multiple is that x. So we simply have that x equals 0, which if you put in 0, 0 squared is 0, negative 8 times 0 is 0. That checks out. So now do the same thing here. We're going to take this multiple and set it equal to 0. By subtracting 8, we can solve. And x equals -8. And again, you can check it. -8 in parentheses squared is a positive 64. -8 times -8 is also positive 64. Okay. Let's get this one into standard form because it does not equal 0. To do that, I am going to subtract x from both sides, and I'm going to subtract 3 from both sides. So I get 2x squared minus x minus 3 equals 0. It would have been a less step to subtract over that 2x squared, but you want to keep this x squared term positive, and so that's why I moved 2 terms over versus just moving the 1 over. Okay. This is in standard form. Because this number here is not 1, because it's something other than 1, that makes this fourth type what I call a hard trinomial. Hard trinomials is when a does not equal 1. Easy trinomials, your a does equal 1, which is what we had here. We had a 1x squared. But now here I have a 2x squared. When this happens, I call it a hard trinomial. It's not really hard. It's just an extra step. You still go about it the same way. I don't have a GCF. I can't divide 2, 1, or -3 by the same thing. So let's go into our x again. My a times c is 2 times -3. So this is -6. My b term is -1. What adds up to b but multiplies to ac? I'll give you a minute to think. It's actually these two numbers right here, -3 and 2. -3 times 2 gives you -6, but when you add them together, you get the -1. You do need to be careful with signs here. If you say +3 and -2, that does still multiply to a -6, but it will add up to a +1. So you've got to be careful with these signs. Okay, so here's where the extra step is. Once we fill in our x and we figure out what multiplies to AC and what adds up to B, you have to take this middle term, in this case, my -x, and rewrite it using these numbers here. So this becomes 2x squared minus 3x plus 2x minus 3 equals 0. I dropped down my first term, I dropped down my last term, and I took this middle term here and rewrote it with these two here. I did not change my problem. In a way, I unsimplified, because if I'm to combine these back, -3x plus 2x gets me back to this -x. Once you have 4 terms here, you're going to factor by grouping. You're going to group your first 2 terms together and your second 2 terms together. So what is my GCF of these first 2 terms? Well, I can't divide 2 and 3 by anything, but I can divide out an x because I got an x squared and an x. When I factor out an x, 2x squared divided by x is 2x. -3x divided by 3 is -3. If you distribute back, you get back to that 2x squared minus 3x. Do the same thing here. What can you divide into 2 and 3? Or I should say 2x and -3. And here the answer is nothing. So that makes your GCF 1. If you can't factor out anything, you need to kind of put a placeholder of 1 because we're going to need this later. So my GCF is 1, which means I am left with the same thing. And now notice we have 2x minus 3 in both parentheses. These need to repeat with each other. So this factors to 2x minus 3. You're going to use one of these. And then your other binomial is what you factor out as a GCF. So x plus 1. So now use your zero factor property and take both multiples and set them equal to 0 and solve. So I have 2x minus 3 equals 0 and x plus 1 equals 0. Here we're going to add our 3 and then divide by 2. So we get x equals 3 over 2. And here we're going to subtract 1 and get x equals -1 for our two solutions. Notice that all of these here had two answers to their problem. Sometimes those answers will repeat. So sometimes you might get like x equals 4, x equals 4. That's still two answers. Okay. You'll always get two of these because these are quadratics. So once we go to cubics, once we get x to the third, once we get x to the fourth, we're going to get 3 and 4 answers. Whatever that highest degree is, tell me how many answers I have. So I knew by looking at all of these that I'm going to have two answers for all of these problems because they all have a degree of 2. If you need more help with this, please reach out. This is all the review that this class has time for. But if you're in the companion, I have 3 lessons, little mini lessons over these 4 problems. So this is literally a fast, quick review. If you need more review than what this video is, please reach out and I will send you some supplement videos to watch.